My name is Camille Cobb, and today I'll discuss a privacy-focused systematic analysis of online status indicators. This work was done in collaboration with Lucy Simcoe, Yoshi Kono, and Alexis Hineker, all of whom work at the University of Washington. The majority of this work was completed while I was a student there as well, and currently I'm a postdoctoral researcher at Carnegie Mellon University in the SciLab. Online status indicators, or OSIs, are interface elements that convey whether someone is online. For now, you can think about the green dots that you've probably seen in popular apps such as Facebook, Slack, or Skype. But after this talk, you'll have a much broader understanding of what OSIs might look like. Importantly, I want to distinguish a couple of things that are not OSIs. For example, read receipts and typing indicators and lots of other interface elements might reveal that someone is online, or when they were online previously, but their main goal is not to show whether someone is online, and so these were out of scope for this study. OSIs have been around for a really long time. In computer science research, going back at least a couple of decades to the early 2000s, we see that they were initially used in instant messaging and chat apps, like shown here from AOL AIM. They were specifically studied and developed with workplace environments in mind. Some of the envisioned benefits of OSIs were that they could help people easily assess whether they could expect a quick response, or figure out if their colleagues were back from lunch yet, or figure out whether it's a good time to interrupt someone with a question. Lots of different OSI designs were considered, some aiming to estimate people's availability rather than their mere presence. And they would do so potentially by learning from behavioral patterns, like when people are usually online each day, or by including input from diverse sources like users' calendars, or even by adding physical sensors to their office spaces. In terms of privacy, Nardi et al. In 2000 found that plausible deniability was an important feature of OSIs in the workplace. That is, it was important that people could say something like, "Oh, that's funny that it said I was online. No, I stepped away for a while and I just saw your message," regardless of whether that was true or not. As I'll discuss today, OSIs now exist in a wide variety of apps, including those that we use throughout the day and that we use on our mobile devices, not just desktop computers, and that we use for social and not just work purposes. So it's important to consider how they currently affect our privacy. Prior work has found that patterns of app use correlate with real-world and online activity. Buchenscheid et al. Studied OSIs in WhatsApp, which is a popular chat application, and found that OSIs can reveal what time people wake up or go to bed. You can tell if people are using apps while they're at work, which might be against the rules. You can see when there are deviations from people's typical schedules, which might mean that they're on vacation. And in some cases, you can see when people are having synchronous conversations using the app. Doe et al. Found that which app you're using is predictive of your location and vice versa. So, although they weren't studying OSIs specifically, OSIs represent a feature that can broadcast the same type of information to other users, and there might be privacy risks that have the same type of information leakage. In our own follow-up work published at CHI 2020, we found that many users contort their behavior to achieve a desired self-presentation via OSIs. For example, one participant in that study said, "My ex would notice if my online status is irregular or weird, so I would keep a schedule of being visible so I don't rouse suspicion." We also found that users do frequently make inferences about each other based on their OSIs. For example, one mother said, "My son seems to go offline when I get online," and she had inferred that he's mad at her for not liking his girlfriend. In some cases, participants discussed actively observing others' people's OSIs rather than just passively kind of noticing them while they're using the app. For example, one participant said she sometimes checks to see if her mother or sister have been online. That way she can know whether or not it's okay to text them without waking them up. So it's been established that OSIs can potentially leak lots of information about users. But how widely does this apply? And how do specific aspects of OSI's implementation affect users' privacy? Our goal with this study was to conduct a systematic analysis of OSIs that would allow us to consider how characteristics of OSIs might affect users' privacy. To limit the scope of this analysis, we consider only mobile apps. So we asked, which apps and what types of apps have OSIs? Are OSIs still just in work-related or instant messaging apps? What other types of apps have OSIs, and what does it imply about their privacy characteristics to have OSIs in apps of certain domains. How do OSIs look and function in various apps? For example, do they still offer plausible deniability in terms of how closely the OSI reflects actual user behavior? And do they allow users to control when they appear as online? What other design features might affect users' privacy? So to start, we identified 184 apps for analysis. Because our goal was a comprehensive characterization of OSI designs, we wanted to identify as many apps as possible that had OSIs, and we wanted to make sure that we were considering apps from a variety of app genres. So we used a diverse set of criteria to identify these 184 apps, which you can read more about in our paper. We manually downloaded each of these apps on 2 phones so that we could create 2 accounts that would become friends with each other, and we then performed a loosely structured analysis to figure out which of the apps had OSIs and what features of OSIs we should be considering in terms of our systematic analysis. We found 40 apps that have OSIs, and we also used this initial analysis process to develop a systematic protocol for app analysis. For example, it was important to make certain observations before the accounts were linked as friends or contacts, but because certain apps require that users create an account via Facebook and then they automatically add your Facebook friends as friends in this new app, it was important that we had to make pre-friendship observations in those apps before connecting the accounts on Facebook. So there are more details on this process in the paper. So looking more closely at these 40 apps with OSIs, before even considering some of the specific OSI design characteristics, we can see that online status information in some apps might be especially sensitive or revealing, going beyond the privacy risks that were identified in prior work. For example, someone who sees that I'm online in a dating app, like one of these, might infer that I'm single. If I stop coming online regularly in those apps, they might guess that I've started seeing someone. Several of these apps are related to gaming or entertainment. So, in the cases identified by Buchenscheid et al., where they could see people coming online during work hours, maybe it would be especially damning if they were playing games during workout. In our own follow-up work from Kai, one participant noted that they were confronted about their video game habits. They said, I had a friend message me to tell me they thought I was playing video games too much. I was offended by this and left my status as offline permanently after this situation. Given the prevalence of OSIs in popular apps, many users probably use multiple apps that have OSIs. For example, I use 6 of these regularly. This could mean that a hypothetical adversary could account for a pretty large percentage of my online behavior. Or they could observe patterns in terms of my simultaneous or sequential use of these apps, which might give them even more information about my behavior than my use of just one app. So we characterized OSIs along 4 axes. I'll talk about their appearance, audience, connections to user behavior, and the existence and implementation of settings for OSIs in each of these apps, and how they vary for different apps. Appearance is probably one of the things that users would notice first in terms of differences between OSIs. At the beginning of this talk, I gave the example of green dots, and I chose that because 19 of the 40 apps that we studied have OSIs that appear with a green color and a dot icon. Also, in the Kai user study, we found that most participants were able to recognize green dots as OSIs, even with very little additional context. However, other icon shapes and colors have been used as well. So for example, even though Slack's default OSI is a green dot, users can change the color scheme, which can affect the color of their OSIs. So in these screenshots, we see a bright green dot against a navy background, a white dot on a brown background, and an orange dot on a teal background. Also, users who are single channel guests in a Slack workspace will appear with a triangle rather than a dot icon, as shown here in the default color scheme. OSIs can also be conveyed through text. So for example, in WhatsApp, the word online appears under a user's name if they're online. Text is sometimes used to give more specific information. For example, in WhatsApp, if a user is offline, the text will reflect what time they were last online. In PUBG Mobile, when users are online but not currently playing one of the games available, their OSI will show up as blue text that says idle, and if they start playing one version of the game, then the text will change to orange and say this one is the classic mode of the game, and then show in parentheses right after how long ago the game was started. These additional details may create an increased privacy risk. So for example, in WhatsApp, the fact that last online time is shown means that it would be really hard for someone who stays up late at night and is on their phone during that time to hide the fact that they were up late from their early rising friends. Moving on to audience. It will likely come as no surprise that one factor for determining an OSI's audience is whether or not the OSI is visible to everyone else in the app or just people you're friends with. We found 21 apps whose OSIs were only visible to friends, by default at least. And we found 14 apps whose OSIs are by default visible to any other user of the app. This includes all of the online dating apps. One might ask whether it's a desirable design choice in the context of meeting strangers through online dating for them to always be able to see whether you're online or offline. Users' relative location in the app can also determine the audience of an OSI. To illustrate this, I'll use an example of Alice observing her conversation with Bob in Google Hangouts. When Bob is online, text at the top of their conversation view will say, "Active just now." This is a typical OSI. In Hangouts, typical OSIs are visible only to people who have been added as connections. But also notice the small profile picture icon in the bottom left. In this screenshot, it's fully opaque, but it could also appear slightly transparent or lighter in color. In this case, the difference in appearance conveys whether Bob is also currently viewing their conversation. We call this a sub-area OSI. Perhaps surprisingly, Alice would be able to see this sub-area OSI even if she and Bob were not friends yet, which is different from the typical OSI's audience. Sub-area OSIs are not always limited to a conversation view. So for example, in Slack, all OSIs are sub-area within a particular workspace. A third type of OSI is the cross-app OSI. For example, users on Facebook can see people who are online in Facebook Messenger, even though that's technically a different app. How closely an OSI is connected to user behavior is determined partly or mostly based on how long and how consistently the timing for people to show up as online or offline after they open or close an app. Continuing the previous example of Alice and Bob chatting in Google Hangouts, at least from Alice's perspective, when Bob stops using the app, after about 15 minutes, his typical OSI will change from saying "active just now" to "active 15 minutes ago." And then if he opens the app again, then it'll be fairly quick for his, like a few seconds, for the OSI to once again update to say "active just now." His sub-area OSI, whether he's leaving or the conversation or coming into the conversation view, will update within just a few seconds. So that's quite different from the typical OSI's behavior. Across all of the apps we studied, we found a broad range in terms of the time it takes for users to appear as online or offline after they open or close the app. For example, in Slack and several other apps, OSIs update within just a few seconds for people coming or leaving the app. In Battle.net, it takes several hours for a user to appear as offline. And Coffee Meets Bagels OSI only specifies whether the user has been online within 72 hours. We didn't systematically measure differences in how consistent the time to online or time to offline was for each whenever a user opens or closes an app. But anecdotally, we did notice differences between apps, and we noted that for some apps, the time to offline varied depending on whether the user simply closes the app or hard quits it. Whether or not these differences in length and consistency of timing represent conscious design choices, they will impact how closely someone can monitor another person based on their OSIs. More quick and consistent updates mean that the OSI will correspond more closely to real behavior, which will allow really fine-grained monitoring of the person. And it also minimizes the opportunities for plausible deniability. But OSIs that take longer to update might be less beneficial, and it might be harder for users to correctly anticipate what their OSI will look like to others if it less closely matches their actual behavior. Several participants in our follow-up study also expressed frustration about being bombarded with messages as soon as they sign on. In 30 of the 40 apps that we studied, people show up as online within just a few seconds of opening the app. Perhaps some users would prefer a slower time to online. OSI settings are another way that users can intentionally cause their OSI to not perfectly reflect their behavior, at least in some apps. Half of the apps we studied do not allow users to control their OSIs. And of the online dating apps, only Grindr provides OSI settings. And this was a newly introduced feature between November 2018 and 2019. And it was only available for premium or paid users. Of the 20 apps that do provide settings, There are lots more questions that a user might need to answer in order to understand how changing their setting will impact their self-presentation via their OSI. For example, can I specify how many people or groups can or can't see my OSI? Only 2 of the apps that we studied allow you to specify specific individuals that you might want to hide your OSI from. If I change the setting, will people be able to tell? Even in the apps where turning off OSIs causes users to appear as though they're offline, a user could easily give themselves away by doing things like liking or posting content in the app. And then people would know that they were actually online, even though they appear offline, and that they have their setting turned off. There are also several other ways that an adversary could potentially detect someone whether someone's changed their setting, which we discuss in the paper. If I turn off my OSI, will I still be able to see that other people are online? For 10 of the 20 apps with settings, yes. Although enforcing reciprocity may seem like a natural choice, it could result in coercive contracts. If my boss, who is typically at least in a position of power over me, wants me to be able to see their OSI so that I can, for example, stop messaging them during important meetings, in many apps, in order to see their OSI, I would also have to share my OSI, even if I preferred not to. So in this paper, we give several relatively straightforward design recommendations based on existing OSI settings. We think that app designers should ensure that OSIs are recognizable and salient, which they might be able to do by reusing some of the common design characteristics, such as the green dot OSI, or using text that explicitly states what's being conveyed. So for example, the text online now next to someone's username seems pretty straightforward. Users should be able to easily anticipate how their OSI will reflect their behavior. This may seem at odds with OSIs that offer plausible deniability, because it's easiest to anticipate how your OSI will appear if it correlates exactly with your behavior. But we hope that designers can consider ways to achieve both goals. For example, this could be achieved by showing users their own OSI, like showing me what my OSI looks like at any given time, or by having less consistent or longer time to offline, along with OSIs that are more vague in terms of what they convey, such as has been online within 72 hours that is used in Coffee Meets Bagel. App designers should provide OSI settings, and probably they should provide ones that allow users to covertly appear as offline, and probably they shouldn't require reciprocity or shouldn't enforce reciprocity. Other design recommendations that we surface are less straightforward or deviate farther from existing implementations. For example, could apps rate limit the frequency with which someone could query another user's OSI, or apply concepts from differential privacy to limit the number of times any one person's OSI can be viewed, potentially providing theoretical guarantees about the inferences that adversaries could make. Should apps let users know when someone views their OSI? Maybe they should only let them know if the person is repeatedly viewing it throughout the day for a long time. Could apps allow users to preset a schedule determining when their OSI settings should be turned off? For example, maybe I want my OSI to reflect accurately during work hours, but never show me as online in the evenings, because I don't want my coworkers to see that I'm working and decide that it's a good time to ask me questions. Since apps currently only allow users to appear as offline, even if they're actually online, would some users prefer to appear as online? Although this would potentially undermine useful aspects of OSIs, it could likely be implemented by a third party without requiring buy-in from app developers. Finally, since users are potentially juggling OSIs across many of the applications they use and trying to anticipate and control them, like toggle the settings in multiple apps and anticipate how they'll appear, would users benefit from a third-party OSI manager that allows them to turn OSI settings on and off, or see how they currently appear to others in that app? So in this talk and in this paper, we've presented a privacy-focused systematic analysis of online status indicators. We identified 40 apps with OSIs and taxonomized 4 dimensions of OSI characteristics: appearance, audience, connection to user behavior, and the existence and implementation of settings. And further, we've surfaced privacy-focused design recommendations that could give users more control of their self-presentation via OSIs.